In the beginning of chapter 8, we talked about adding and subtracting polynomials. Now we're going to talk about multiplying, but in this section, we're just going to multiply a polynomial, which is going to have 1, 2, 3, 4 pieces or more, by a monomial, meaning we're just multiplying by one term. So a reminder as far as rules for exponents. When you're multiplying bases that have exponents, you add the exponents together. So for example, in this one right here, x to the fifth times x cubed, we do 5 plus 3 and get x cubed. However, in this one, when we have a power raised to a power, we multiply those together and do x to the 15th. So just to make sure you understand, these first five problems here, I'm just trying to remind you of rules we learned before we dive into the new stuff and apply it there. Okay, now on the second one, this is where that reminder comes in, or third one, sorry. So the reminder comes in. If we're multiplying, we have to add the exponents together. 4 plus 4 is 8. Now these two are about combining like terms. You can combine a term if they have the same variable, x, and the same exponent, fourth. So these two are like terms. So we can say 2 plus 3 is 5. We have 5x to the fourth. Now these two are not like terms. While they both have x, they have different variables. Different exponents. My mistake. They have the same variable, but different coefficient. Man, I'm getting my terms mixed up. They have different exponents. That's a 5, that's a 3. So those can't be combined. So this is already as simplified as it can be. There's nothing more we could do to combine those two. So 3 things to remember to correctly do these new kinds of problems. Like I said, these 5 are just reminders of stuff we've done before, but you need to remember to use the distributive property. Got to make sure you use signs correctly. You can lose points easily when you forget that a negative times a negative is a positive. And make sure you remember to combine like terms when possible. So let us begin. Number 1. So k is the monomial, 5k plus k squared is the polynomial, and we're multiplying them together. And like I said in number 1 here, we're using the distributive property. So I do k times 5, so that's k to the first times 5k to the first. So I do 5 for the coefficient. K to the first times k to the first is k squared, because we add 1 plus 1. Plus k to the first times k squared, we do 1 plus 2, which is 3. Number 2, we're going to distribute. So the coefficients, 3 times 2 is 6. Now this is the only x, so there's nothing gets multiplied by it, it just stays x just as it is. But y times y, we have y to the first times y to the first. 1 plus 1 gives us 2, so it's y squared. Now when we multiply the second one, 3 times 4 is 12. X to the first times x squared, we do 1 plus 2, which is 3. And this is the only y as far as these two terms are concerned, so we just leave the y as it is. Okay, now we get even more fun. So we've got this big monomial, big single term, times these 3 terms, it's trinomial. So we distribute. So negative 2 is the only coefficient we see, so we just leave it as negative 2. M squared times m squared, so 2 plus 2 is 4. N cubed times n to the first is n to the fourth. So that's the result of us multiplying by the first term. Now the second term, negative 2 times negative 2 is positive 4. M squared times m to the first, we get m cubed because 2 plus 1 is 3. N cubed times n squared, 3 plus 2 is 5. So that's the result of us multiplying by the second term. Okay, last one, negative 2 times 2 is negative 4, but there's no other variables or coefficients here, so the rest of this term just stays just like it is. It's only negative 2 times 2 that changes anything. We just leave it m squared times n cubed. So that's the result of this monstrous multiplication. So as you may have noticed, it's okay if you didn't, we've done steps or key 1 and key 2 already. We've used the distributive property and we've had to pay attention to signs, but it's here on this one we'll start having to think about like terms. Because if you look at 1, 2, and 3, it was just a monomial, then parentheses for the polynomial. A monomial, parentheses for the polynomial. But now we have a monomial times a polynomial, and then they subtract 5x from that result. So this is going to require us to combine like terms after we distribute. So x times 3x, the 3 just stays. X to the first times x to the first is x squared, because 1 plus 1 is 2. And then minus x times 4 is 4x. So this is the result of the multiplying, the distributive property, but we also have to write the minus 5x right here. Negative 4x minus 5x is minus 9x. So after you distribute, check to see if there's any like terms to combine. There weren't in the first 3 we did, but there was in number 4. And I think there will be here as well in number 5. So first is to distribute. We've got 2 things to distribute. We'll do 6a first. 6 times 2 is 12. A times a is a squared. 6 is the inland coefficient. A times b is ab. So that covers this first one. Now, 2a times negative 4a. 2 times negative 4 is negative 8. A times a is a squared, because a to the first times a to the first, and 1 plus 1 is 2. Then we have 2 times 5, which is 10. A times b, which is ab. So that's the correct multiplication. So make sure you got that part first. Now we look for some like terms. Well, I see an a squared here and here. 12a squared plus negative 8a squared is 4a squared. Because plus and negative is the same thing as minus. And then negative 6ab plus 10ab. Negative 6 plus 10 is positive 4. Number 6 is very similar to number 5. We'll need to distribute first, then we'll worry about like terms. So 4 times 2x is 8x. 4 times 3 is 12. Now 3x times x times x is x squared. 3 times negative 4 is negative 12. X times x is x squared. 3x times 5x is 15x. So let's look for the highest exponents first. We see those two right here. A positive 3 minus 12 gives us a negative 9x squared. So that's covered. Then we have 8x plus 15x. Add those two together, you get 23x. And that leaves us with our constant, plus 12. Now, I would encourage you to try the ones on the back on your own, then press play and see if what you got matches what I got. Actually, let me do the first one. Sorry, I realize these are a little bit different because they're equations we're solving. Now, we'll have to use the same kind of methods we were talking about, but there will be a little more work to do because we're trying to find out what, in the case of number 7, is a equal to. So I'll do the first one, then I'll encourage you to pause and do the next two on your own. So just like in the front page, we distribute first. We get 2a minus 6, 3 times negative 2a is negative 6a. 3 times 6 is 18. This is an equation, so we want to combine the like terms. Now they're on opposite sides of the equal sign this time, so I'll need to add 6a to both sides. We get 8a minus 6 equals 18. Add 6 to both sides. Then divide both sides by 8. We get a equals 3. So you can see the pattern there. So now I'd like you to press pause and try number 8, 9, and 10. Once you're done, press play and see how you did. Okay, number 8, I'm going to distribute first. 3 times x plus 3 times 5. Okay, I do have some like terms right here I can combine. 15 minus 6 is 9. Then I can subtract 9 from both sides and get 3x equals 9. Then divide both sides by 3 and get x equals 3. It's pure coincidence we got 3 twice in a row. It certainly can happen. You get the same number twice in a row, but it's not common. Okay, number 9, we need to distribute first. 3 times t squared is 3t squared. 3 times 2t is 6t. Okay, so good news. If you notice, the two terms with t squared are going to cancel each other out, because we have 3t squared on both sides. So if we subtract 3t squared, poof, they're both gone. We have negative 6t equals 5t minus 11. We do need to combine the t's, so I'll subtract 5t from both sides. Get negative 11t equals negative 11. Then we'll divide both sides by negative 11. Get t equals 1. Okay, on number 10, we actually have two things to distribute. Obviously, we distribute the 3, so let's do that first. 6n minus 18. And then this is like distributing, because we need to distribute the negative sign or the minus sign through. Because it's minus 2n minus 1. So I'd recommend we go ahead and combine the like terms that are on the same side. So ignore the 9 right now. Let's just simplify this left side. 6n minus 2n is 4n. And then negative 18 minus 1 is negative 19. Then we'll add 19 to both sides. We get 4n equals 28. Divide both sides by 4. We get n equals 7.